and good afternoon, everyone. Let me just check. Is there a presentation on the screen? Okay, great. So good afternoon, everyone, and it's really great to be here. My name, as Shannon has said, is Judy Beaumont, and I'm the recently appointed director at IOI-SA, and already very busy and thoroughly enjoying it, and very pleased to be here with you this afternoon. So my presentation today is going to really briefly have a look at some of the science. I think many of you who may have had a look at some of the climate change science will know that there's many graphs that show greenhouse gas emissions, etc., ocean warming. So I'll show you a couple of those just in the first few slides. Nothing too serious, and I'll make sure that the messaging is very clear and not complicated. Then we're going to move into a special report by the Intergovernmental Panel on Climate Change, which focused on the ocean and the cryosphere, or cryosphere really being all the areas of Earth covered by ice in a changing climate. So looking at changes in the ocean, risks to ocean and coastal ecosystems, changes in marine life, sea level rise, and adaptation options. And then going into some of the ocean governance response options and implications. And then we'll move into discussion. Some of the slides I may flip through a little bit quickly because they're easy to catch the gist of, and others I'll stay on for a little while. Okay, so just to contextualize ourselves, we know how important our world ocean and oceans are, our world ocean is, and our oceans are. And this graphic just reminds us, important in terms of the air we breathe, important in terms of transportation. An estimated 90% of all world trade involves some form of marine transportation. Important because our oceans provide an absolutely key role in regulating climate. Also a very key role in the ocean economy, with the OECD estimating $1.5 trillion being what the global ocean economy is producing in goods and services. Of course, very critical in providing food, and very critical in providing components of medicines, ingredients of medicines, and even specific medicinal products directly. Okay, so here's the first graph. And the most important thing here is that this that says 0 refers to 1950. And all of the preceding lines are the millennia preceding 1950. And so you can see that the CO2 emissions have gone up and down, up and down, up and down over many millennia, but always stayed below 300 parts per million. And now, since 1950, they have shot up to 420 parts per million. We're close to 420 at current level. So it's a massive change. This will look a little bit muddling, but bear with me. It's just an example of some of the messages that you find in the climate change modeling graphs. So here what you're seeing are indications from the IPCC, Intergovernmental Panel on Climate Change, that has used in this report, special report on oceans, it has used two in particular emission scenarios. So one emission scenario is called 2.6, and that refers to the low emission scenario. In other words, the best possible outcome of efforts to reduce greenhouse gas emissions. The second one, and that one is in blue, the second one is the high emission scenario, and that really is the example of the worst possible emission scenario. So if we just allow our eyes to glance across some of these graphs, you'll see that it says global mean surface air temperature, and the worst possible emissions will take us to a range up to 5 degrees. This axis is degrees temperature, increase in temperature. And for the lowest emissions, you can see that it keeps us below 2 degrees. So the messaging here is that globally, there have to be massive efforts to reduce the greenhouse gas emissions in the world's atmosphere. So the next graph shows you the global mean sea surface temperature under the red high emission scenario and the blue low emission greenhouse gas emission scenario. And here again, you can see that the mean sea temperature in the high emission scenario goes up quite dramatically, and in the low emission scenario is relatively contained. And similarly, the messaging around the number of marine heat wave days, ocean heat content. So the key messaging here is around the difference between what the impact of climate change would be under a high emission scenario versus a low emission scenario. And the messaging, as I said, is that globally we have to ensure that we keep temperature below 2 degrees Celsius increase, or even better, below 1.5. And just having a look here at the global mean sea level, you can see again the high emission scenario, the sea level rise is significant. And this is a range, obviously it's between 2.5 and 5 meters increase, it's a range. But for the low emission scenario, it's completely manageable. It's still within a range of 1 meter. And I've got another couple of graphs, but I won't dwell on them. They're useful though, just to situate ourselves and remind us that we're really talking about significant changes to the global atmosphere with severe impacts on oceans in particular, which is our discussion here. So here we've got the global CO2 emissions have risen steadily since 1960 and up to 2020. I'm going to just flip through these. Again, here you can see the difference between business as usual, that's the gray. Business as usual basically says we don't do anything about climate change. And here you can see the likely temperature increase, 4.1 to 4.8 degrees. Under the current policies of dealing with emissions, it's a better scenario between 2.5 and 3.1 degrees Celsius increase. And if we look at the pledges that have been made by countries through, for example, the Paris Agreement, it's getting better and better. But what we're looking for is efforts to bring us down to a maximum of 2 degrees Celsius increase or 1.5 degree increase. Just another couple of graphs. This one is around ocean warming. And 2018 set a new record of ocean heating, in fact, with the 5 years from 2014 to 2018 being ranked as the 5 warmest years for ocean heat content. And a similar narrative is the case for 2020, with January this year being the 6th warmest over a period of 143 years of monitoring the ocean. So it's significant. Here again is the global sea level rise, again from 1992 all the way up to close to 2020. And the rate of global sea level rise nearly doubled from 1.7 millimeters annually throughout most of the 20th century to 3.1 millimeters annually. So a significant increase, all of which we've got to accommodate in our ocean governance. Here's one more on the annual ice loss in Antarctica, which has tripled, increasing global sea level by 3 millimeters. And you can see the different ice sheets of Antarctica. And this is basically showing the annual ice loss, West Antarctica, the Antarctica Peninsula, and East Antarctica. Okay, so those are the graphs. It just sketches the story, and it's a story that requires dramatic response. And I think a last piece of that story, referring back also to the difference between a 1.5 degree temperature increase and a 2 degree temperature increase, is looking at what the impacts are likely to be and how they differ. So here we've got all the 1.5 degree examples of impacts on the left-hand side, and on the right-hand side, you've got the 2 degree examples of impact. So just as an example, for sea level rise under 1.5 degrees, it's projected that 69 million people could be exposed to flooding. Whereas when we're looking at a 2 degree scenario, we're looking at 80 million. On coral reefs, we are under 1.5 degree scenario, we're looking at 70 to 90% reef loss, and under a 2 degree scenario, we're looking at 99% loss. In terms of annual wild catch decline, under 1.5 degrees, one's looking at 1.5 megatons per year, whereas under 2 degrees, we're looking at annual wild catch decline of 3 megatons per year. So a big difference. So in terms of knowledge for action, the IPCC special report, that's the Intergovernmental Panel on Climate Change, did as I indicated, a special report on ocean and cryosphere in a changing climate in 2019. And really the messaging is around highlighting the urgency of prioritizing timely, ambitious, and coordinated action to address widespread and enduring changes in the ocean and cryosphere. It also emphasizes the importance of empowering people, communities, governments to tackle what really is unprecedented transition, both in terms of the environmental impacts and the social and economic transition that is required. It also provides evidence of benefits of combining scientific with local and indigenous knowledge, and really most importantly focuses on the importance of education and climate literacy. So what does the IPCC special report say? Just in a nutshell, it talks about the importance that the ocean has taken up more than 90% of the excess heat in the climate system. And by 2100, the ocean will take up 2 to 4 times more heat if global warming is limited to 2 degrees, and up to 5 to 7 times at higher emissions. So the ocean is at the moment really what is keeping us safe. And if the emission scenarios continue as business as usual, the ocean is in trouble, and so are we. So ocean warming reduces the mixing between water layers and therefore the supply of oxygen and nutrients for marine life. And that mixing is really critical. And what has been happening is marine heat waves are becoming more frequent and more severe. And those marine heat waves are harming the warm water corals, they're harming kelp forests, and they're harming the distribution of marine life. And of course, once one is tampering with one piece of the ecosystem, it has a knock-on effect. The ocean is also taking up and absorbing the carbon emissions, which has the effect of increasing ocean acidity. It has already taken up 20 to 30% of these emissions, and continued uptake will make it worse. What is the report saying about the risks to ocean and coastal ecosystems? Basically, that these risks increase with the level of warming. And here, some of the key messages are that projected ecosystem responses include loss of species habitat and diversity, and degradation of ecosystem functions. We've already touched on that. We've already spoken about the warm water corals that are at high risk. The most coastal ecosystems, such as seagrass, meadows, and kelp forests, are at moderate to high risk at 1.5 degrees, and the risk increases at 2 degrees Celsius. So again, these are really the foundational elements of some of our coastal ecosystems. And I think the same message is that ecosystems would benefit from keeping the warming at or below 1.5 degrees C. Changes in marine life, basically changes in the ocean cause shifts in fish populations. I think in many countries, this has already been experienced, that fish populations are moving, and it reduces the global catch potential. In some regions, it could in fact either increase or decrease, but overall there will be shifts, and there are already shifts of fish populations. The implications are that communities that depend highly on seafood may face risks to nutritional health and food security. And critical here is the messaging around reducing pressures such as pollution, which enable marine life to deal with changes in the environment. So policy frameworks for fisheries management and marine areas are important, and we'll get back to that. Sea level rise is already being experienced as a significant challenge, and can be expected to get worse. So during the 20th century, the global mean sea level rose by about 15 centimeters, and it's currently rising more than twice that speed, and is likely to further accelerate. And as you can see there, possibly reaching up to 1.1 meters in 2100 if emissions are not reduced. So one of the critical issues here is that extreme sea level events, which don't occur that often now, or mostly are occurring during high tides and intense storms, will become more common. And many low-lying coastal cities and small islands are already exposed to risks of flooding, land loss, and this requires quite significant adaptation to deal in particular with land loss and flooding. So this slide shows basically how extreme sea level events can change over time. Now, what we're looking at here is a once a century. This is the once a century event. And this is what it's always been in the past. We've had once a century high sea level events, extreme events. We've had once per decade, we've had once per year, once per month, and we've had mean sea level. But now what this graph is showing us is that the once a century event could, in fact, if you look over here with the sea level rising as it is, become a once a year event. And once a century events are are extreme. We know we don't often see them. But if that once a century event starts cropping up once a year, it means that there's going to have to be significant effort in, first of all, identifying those areas that are vulnerable to these extreme events. And then secondly, working out what to do. And there are many different approaches. For example, here we've got adaptation responses. You can build hard protection. Those are the seawalls, or sediment-based protection. There's a lot of discussion around ecosystem-based adaptation, particularly for corals and wetlands. There's the approach of coastal advance and coastal accommodation. So do you retreat? Do you try to push out the coastline? How do you deal with particular areas? And obviously it depends what the situation is in a particular area, and it depends how vulnerable and what kind of infrastructure or human settlements may need to be protected. So just a picture of an example of hard protection being, for example, a seawall. It's effective. It can be effective if it is built effectively for quite significant sea level rise. So advantages being predictable levels of safety. The drawbacks, of course, are destruction of habitat, because you're building on top of habitat. And it also costs. These kinds of seawalls are expensive and often unaffordable. The ecosystem-based adaptation option is the other side of the adaptation coin in a sea level rise context. So here we're looking at effectiveness at a lower level of sea level rise. We know that these kinds of initiatives can involve communities. There can be co-benefits of habitats being restored, biodiversity being restored. There can be drawbacks in the sense that long-term effectiveness may depend on what else is happening in the ocean, for example, acidification. And it also depends on effective implementation of conservation policy, strategy, legislation. It's the economic efficiency is probably more efficient than the hard walls, but there are governance challenges, and I've mentioned already the lack of enforcement of conservation policies. Okay, so if we now get into the governance response options, how do we deal with this significant change that is affecting multiple aspects of economic life, social life, and our environment? Now, obviously, these are examples. This is also something from the IPCC, but it's a useful way, I think, of conceptualizing it. And obviously, one would be able to fill in more examples. So here we have, for example, in terms of dealing with hazards of impacts on our coastline. So there can be actions to reduce those hazards. So here's the example of mangroves, cultivating mangroves, restoring mangrove forests to alleviate the coastal storm energy. So to absorb the coastal storm energy and protect the land behind it. There are there's the example of dealing with exposure, actions to reduce exposure. So, for example, risk-sensitive land use planning. And this is a tough one. It requires land use planning legislation to be rigorously enforced. And we know, for example, that our coastal areas are increasingly dense, urbanized and dense areas with infrastructure, with human settlements, with the need for people to find land. And the critical thing is to make sure that the infrastructure, the human settlements, the land use is not taking place in areas that are risky, areas that are risk sensitive, on top of dunes, for example, too close to the ocean. Similarly, actions to reduce vulnerability. And that's making sure that when housing and infrastructure is constructed, it's done in a manner that is not vulnerable to the impacts of climate change. I think one of the key messages here also is that there are limits to adaptation. There are physical limits, there are ecological limits, technological limits, economic, political, institutional, etc. And those are some of the ocean governance challenges that we are facing. Critical here is to remind ourselves of the Sustainable Development Goal that deals with the ocean. So SDG 14, which has a number of sub-targets, preventing and significantly reducing marine pollution of all kinds, sustainably managing and protecting marine and coastal ecosystems, minimizing and addressing the impacts of ocean acidification, bringing an end to overfishing, conserving 10% of our coastal and marine areas, etc. So many of these are the issues that we're talking about. So it's important and it's useful to remind ourselves that we have high-level targets, we have high-level conventions, we have high-level frameworks that are guiding this work. So it's not starting from scratch, but it's making sure that ocean governance is responsive and is able to anticipate the kinds of changes that are going to take place over time. So examples of governance challenges when implementing responses to ocean and coastal impacts, climate change impacts. They're not rocket science, they're the ones we know about. Climate change impacts and consequences operate on time horizons, which are longer than those of governance arrangements. And we know this well from the environmental sector in general. The time horizons generally are longer than planning cycles, decision-making cycles, cycles of financial instruments. Climate change, however, and the impacts of climate change add a new spin in the sense that the impacts are potentially going to be ramped up and the impacts are quite unpredictable. I think that the work that is being done globally to model what the impacts are likely to be and to anticipate what emission scenarios are the ones that are achievable through the work that is being done under the United Nations Framework Convention on Climate Change. All of that helps us, but we are in a space of unpredictability and significant change, requiring significant transition, social and economic transition. Secondly, governance arrangements are in many contexts, many of the countries that we're working in, we know how fragmented these governance arrangements are. And it's because the ocean and coasts cross administrative boundaries, they cross sectors. There are multiple sectors that need to work together to provide integrated responses to these increasing and cascading risks from climate-related changes. Then, of course, there's the financial, technological, institutional, and other barriers associated with implementing the kind of strategic responses that are in the pipeline to deal with the negative impacts of climate change, of climate-related change. And as normal with many of the environmental challenges, adaptive capacity differs between as well as within communities and societies. And the people with the highest exposure and vulnerability are often those with the lowest capacity. and we need to tailor our responses to address that. So how do we strengthen ocean governance response options, and what are the enablers? These are just examples. We need to implement policies and strategies to reduce other pressures, and that goes back to our SDG 14. So pressures such as pollution, modification of habitat, to make it as easy as possible for ocean species and ecosystems to adjust in the changing environment. We need policy frameworks for integrated water management, fisheries management, integrated coastal management, and networks of protected areas, which offer opportunities for people and species to adapt. And I think these integrated policy frameworks are really critical, because as there are changes, so the different sectors have to be able to communicate and strategize together. We've spoken a bit about nature-based adaptation, such as ecosystem restoration, which is critical, and we've got to bring together community knowledge and support, science-based knowledge, and connect all of this with local knowledge to make sure that nature-based adaptation is effective. We've got to focus on intensifying cooperation and coordination across the scales, across jurisdictions, sectors, policy domains, and planning horizons. We need to strengthen investment in education and capacity building, address social vulnerability and equity, and one of the critical things is ensuring that there's regional and transboundary cooperation, such as treaties and conventions, considering once again that our ocean and oceans are interlinked and they do not stick to administrative boundaries. So what are some of the really positive developments that are already out there to support effective ocean? And here I think we're coming to the end. But it's useful to remind ourselves that in fact there is a lot of work going on out there. There's widespread adoption of key international ocean agreements. So for example, the UN Fish Stock Agreement, the MARPOL Convention, the Draft Convention for the Conservation and Sustainable Use of Biodiversity Beyond National Jurisdiction. So there's a lot of work at the international level, and there's a lot of at the global level, and there's also a lot of work at the regional level. And I think the focus on regional, whether it's Indian Ocean, Western Indian Ocean, whatever the regional level is of working together, it's important that our national efforts all add up and create a coherent response at the regional level and ultimately at the global level. So another important positive development is the growing use of marine spatial planning as a tool and strategy to promote more coherent ocean management across ocean users. And I think really worldwide, there are efforts and initiatives and processes of negotiation to put in place marine spatial plans. And they're not easy. There are many practical and legal challenges, because really over the decades, the ocean has been used by multiple users in a manner that has not been managed in the same way that terrestrially we have managed the use of our land. And so marine spatial planning is really a process of negotiation to work out what uses, who is using the ocean in which areas from a national perspective and from a regional perspective, which of those uses, ocean uses, are compatible, which are not compatible, and how do you manage the interface between compatibility and incompatible ocean uses. There are many efforts to expand marine protected areas, also under the Convention on Biodiversity. And there's also widespread implementation of integrated coastal zone management and both from a policy and legal perspective. Those frameworks are in place quite widely, and that provides a basis for that integrated and cross-sectoral conversation. There's increasing use of satellite-based ocean and coastal information and management systems to support decision-making. And here, the trend towards the use of big data and big data systems are really helpful because it enables these kinds of large ocean and coastal information management systems to provide feedback to support decision-making. And there are also efforts to promote the decarbonization of the maritime sector. It's one of the sectors that is taking trouble and starting to move towards decarbonization under the IMO strategy. So colleagues, I think that is it. It gives you, it's a very quick and rough overview, but it does give you a sense of some of the challenges that we're facing from an ocean governance perspective, and are likely to face increasingly as time goes on. We're working in a changing space. We know that every year the international negotiations under the United Nations Framework Convention are taking place, and they are slow, but they are moving forward. And increasingly there is pressure globally to reduce emissions, to ensure that there is finance to support developing countries in their adaptation. There's technology to support developing countries in their adaptation efforts, and there's capacity. Shannon, thank you. Back to you.